Hello and welcome to the second episode of the IoT Industry Bartalk. I'm glad you joined us today. My name is Madeleine Mickeleit, the Managing Director of the partner network IoT Use Case. So a fundamental change is currently taking place in the mechanical engineering sector. The best machines have been built and successfully maintained in the market for decades. Currently, however, the market segments are shifting and established structures are under attack. As a result, differentiation in the market is required in order to meet new customer needs, even though for the long term. I guess no one in this round doubts this today. But the way to get there is seen completely different by the providers. So what will the machine of the future look like? What does the mechanical engineering sector demands here? Today we are asking TRUMPF for their demands to the world of automation. We are curious to see what answers the companies SICK, Harting and B&R will provide today. It's really not a matter of course that they are here today and speak so openly. These are our guests. So Jens, to start right away, you're the market and technology leader of machine tools and lasers. Many customers out there know your business, but to get a practical view, where and how are your machines used in the field?
Maybe one of, or the most important machine that we have is the 2D laser machine. And actually laser cutting works in a way that you use light that you cannot see to cut steel, any kind of geometry in a really outstanding velocity. And the key is the flexibility, and our customers usually are smaller ones, around maybe 30 people, and they really produce any kind of sheet metal parts for any kind of industry.
So small, medium-sized company mainly.
Yes.
I see. So today we want to talk about industrial IoT, a big buzzword, but we want to make it a bit concrete today. And I want to know, to jump a bit in the practical side of your customer, what are the challenges you're facing today in this context for digitalization?
First, in general, over the past years, we saw that the lot sizes getting smaller and smaller. On the other hand, the laser machines, for example, the laser power, became faster and faster. And the question is, at the end of the day, are you able to bring the full potential of productivity in everyday life?
Okay. Do you have some measurable KPIs for us here?
Yes, we have. The value that we usually take is the beam-on value. That means how much of the time when the laser is switched on are you actually cutting? And the value is 38%. It could be 80% in a perfect world, so we could double the value.
Okay, so in this round today, maybe we could formulate a concrete goal for today. What would be your goal for your machines, maybe for the future? Do you have one goal we could use for this talk today?
I would say our end vision is to have autonomous machines. Machines that are able, they have a perception, they can understand what is happening, and they are able to react, adapt to unknown situations. That is the ultimate goal for the machine tool world.
Okay. And when we now take this topic into a concrete demand in the practical side, so what would the one demand be to get this data, to understand the data? What would that be?
So we somehow have to translate what's happening in the real, in the physical world, into the cyber world.
Yes.
And the sensors have the job exactly to do that.
I see. So, the demand is kind of clear, I guess. So what do I need from the sensor part, from the component part to do that? What would be your answer here?
So if we want to fulfill the requirements which Jens formulated, I think it's really essential that our camera systems of the future will have a complete different data output. If we are thinking about live streaming cameras, if we want to transmit images via a network, we need a new kind of ecosystem for the connectivity, for the network, and for this data infrastructure to bring the data in a proper quality, which also means real-time aspects, time synchronization, to this data scientists in the data lake, that the data scientists are able to use these data and create this added value and benefits for the machine and for the end customer.
I think that data quality is really, really important. If you have some high potential data scientists and they are only working on confused timestamps, that will not create any value.
When we now, you just mentioned the infrastructure or the integration of the data, that will be the next step. So now we have the sensor part. When we are focusing now the customer side and the infrastructure at your customer, you really need to get the data at first. So how do you, what would be the demand here to get the data from your customer side, from the infrastructure?
So, as I mentioned, our customers are usually small and mid-sized companies, and we just recently learned how we can handle that because we create a new business model together with a Munich Re. It's not the customer buy the machine, but they pay per part. For each part that is cutted, they pay. And our job is to somehow control the machine or the operation remotely. In order to do that, we've installed 12 cameras in one single machine. And the end was that the network at the customer was not able to handle that anymore. And of course, we have to overcome that. My demand fixed that.
Yeah, good. So the pay per part topic, it's a really interesting topic. I guess we could make an own session for that. But I want to focus on the infrastructure and the network part you just mentioned. So Emma, I hope the demand is clear. You are our expert here for the network, for the control side. I guess we know this topic OPC-UA since years. Now we have the new topic OPC-UA over TSN. So what kind of technology do we have here and how does that solve the demand we have?
I think we can solve it now because, as you mentioned, we have OPC-UA for the semantic interoperability. And on the other hand, with TSN, with time-sensitive networking, we have exactly this network which provides the bandwidths. It's based on 1 gigabit. And also we have this synchronization. So every participant in the network works synchronized. So we have all in our hands. Just we have to begin to start to integrate.
It somehow sounds like really nice, but it somehow sounds like the pitch that we already had from many companies several years ago. So I really ask myself, what's new?
Yeah, you're right. Back in the days, of course, everyone or every automation supplier propagated his own solution based on real-time Ethernet. But now the situation is totally different because take into account that TSN is an IEEE standard which comes in every, let's say, new Ethernet chip. So it's not something which is coming from B&R or from any other. It's standard Ethernet, or it will become standard Ethernet. On the other hand, OPC-UA is also an open technology. And together now we have the good situation that we have now the synergies from TSN technology combined with OPC-UA. And this is a game changer because it's absolutely independent from any vendor. The technology belongs to the 840 members of the OPC Foundation, the consortium behind OPC technology. And this is what exactly you need because you want to get rid of these, let's say, to be prisoned in this golden cage where everything works perfect. But if you want to step out beyond your machine, maybe to the previous machine or to a next IT system, then you can do it now independently from any vendor.
So now we talked about the sensor part, we have the control and network part. The last part would be, so you from the Harting side is all about the cabling. So I think it's about the cost efficiently design of a machine because you are selling your machine as a bundle, right, to your customer. So what would be the demand here for the cabling?
maybe we have to understand how we can work with data. First, we have to collect the data. Then we can work on the data. For example, creating machine learning models, and that takes some time. So there is a gap between, or we have a chicken egg problem. First data, then the application, and we somehow have to bridge that time. And if it's very expensive, we will simply not start. So it's obvious that we have to reduce the costs for handling that big amount of data.
Okay, so what's your answer then? I guess Joachim, you're our expert here for the cabling. So what is your answer there?
I think that the connectivity and the cabling plays an essential part, especially the costs, because otherwise, Jens, you will not sell even one machine if the costs are too high. And if I heard a lot about more cameras with a bandwidth of and data rates of approximately 1 gigabit and even more, we need to go away from the typical field bus systems and move forward to Ethernet communication. And if we increase the number of devices, we at the same time need to simplify the cable. Otherwise, it will not work. And here I would like to introduce a third technology. It's called SPE, Single Pair Ethernet. And Single Pair Ethernet is the Ethernet transmission by just one single twisted pair. So it's cost efficient, it's advanced with regards to sustainability. It's really a perfect technology. And there is another one. So I have brought here a camera, a vision camera of company SICK with me. And Manfred, if I look at you, or if you look at the sensor, sorry for the question, anything strange?
Yes, I think it's it's obvious that the connectivity, the two connectors on such a kind of camera is really, from the housing and from the construction point of view, not really efficient. And this is exactly our pain point, and there is the space for improvement.
Space for improvement is a good wording, I would say. So we can, to bring it to a point, so that the width of the sensor, of the camera, is defined by the two connectors used. And this is not a good and cost-efficient way for the future. And with single pair Ethernet, you have one cabling technology, so you could use the connector for the data transmission as well as for the power supply. There are two ways, for example, power over data line, PUDL, or to use a hybrid connector. But it's the one cable technology really to build up miniaturized, cost-efficient and sustainable devices and cabling.
So Jens, you heard we have 3 demands of you, we have 3 answers here. Are you happy now? Is that the way to go, where you say, okay, let's start? Or?
I really appreciate it. And to be honest, I have to admit that it's really also being a little bit brave in your business to be that open. But there's no doubt we will only be successful in that open system.
Yes. I just want to point out, you just mentioned the word co-opetition. I guess this is one thing which is really important, to get in co-opetition and a very open mindset to work in an open ecosystem, for example, like the OPC Foundation. And now...
That's true, It took a little time, We have had to negotiate what standard will come out of this. But on the other hand, we all know that we created 15, 20 years ago, we created real-time Ethernet solutions based on proprietary protocols. And now we have the problem that people or machine builders, our customers, don't want to be prisoned in that golden cage anymore. Yes. They have to, let's say, exchange data with the previous machine, the next machine, with other systems. And therefore, interoperability is key. And there is no way of really sitting together and designing a global production language together with all requirements for the important field level.
We didn't like it 10 years ago, but it's obvious that for the future, it's not possible to do it in the way we did in the past.
We learned all.
I think this is also for us as a sensor component supplier, which have to be integrated in different infrastructures from automation suppliers in IoT systems. We need definitely a much better ecosystem for the integration, for the networking, and for the communication. And this brings so much benefits for the customer or for the application engineers to use the data very efficient. So the data scientists can really plug and play, use data and bring the added value in a much faster and more efficient way.
Yes, and this is a really good end statement for today. So we have the competition, we have the ecosystem, and the open mindset. Thank you very much that you're part of the round today. It's really not easy to talk that open. Thank you, Jens, for your statement from TRUMPF, and thanks for our round.
It was a pleasure. Thank you very
Thanks.
much.
Thanks for having
It was a
me.
pleasure.
I'm very glad you joined us today. In episode 3, we are looking at business models and new technologies currently being implemented using the example of Anheuser-Busch, the worldwide biggest brewery. Do you have any questions about controllers and OPC UA over TSN? Contact B&R. Smart sensors, please feel free to contact the company SICK and SPE Harting. All information and contact options can be found through iotusecase.com/Bartalk. If you would like to learn more about our network or discuss your use cases, please feel free to contact us directly. We're looking forward to learn more about your use cases.